This session is for OCR FP2, topic is differentiation, and we're looking at question 6 from June 2010. So just looking at what we're asked to do, part 1 says that we've got to show that the derivative of the inverse sine of x is equal to 1 over the square root of x squared plus 1. And in part 2, given that y equals cosh of a inverse sine of x, where a is a constant, show that x squared plus 1 lots of d2y by dx squared plus x dy by dx minus a squared y is equal to 0. So let's start by looking at part 1. And part 1 really is this bookwork sort of question that you should have practiced before and be familiar with the technique. So we'll let y equals inverse sine of x, which means that sine of y is equal to x. And then we can differentiate implicitly, so we end up with cosh y dy by dx is equal to 1, and dy by dx is equal to 1 over cosh y. Now, we must give our answer in terms of x, so we just need to use the identity that cosh squared y minus sine squared y is equal to 1, and substituting in the fact that sine y is x squared. So cosh squared y is equal to 1 plus x squared. So this is going to be 1 over 1 plus x squared, or x squared plus 1. So just 2 marks for that question. So there was 1 mark, really a method mark here for rearranging and differentiating, and an accuracy mark for substituting in at the end. So 2 marks for that part. If we look at part 2, then we're going to need to find dy by dx, and we're going to need to find d2y by dx squared. So let's just have a look at this. So cosh, y equals cosh of a inverse sine. So we'll differentiate. So this first part we're going to use the chain rule, or function of a function. So we'll differentiate cosh to get sine, and then we'll need to multiply by the derivative of a inverse sine of x, which from part 1 we know is going to be a over the square root of x squared plus 1. So we now have our first derivative, and we're now going to need to differentiate again. So this time we have a product rule that we need to use, and within the product rule we're going to be using a function of a function. So it's v du by dx, u dv by dx plus v du by dx, or either way around, it won't matter. So we will leave this first bit and we'll differentiate a over the square root of x squared plus 1. So we're writing that as x squared plus 1 to the power of a half, and just differentiating carefully we should get minus ax over 1 plus x squared, or x squared plus 1, and I'm going to use sort of fractional powers now because that's what we will do when we're differentiating. And then this time we're going to differentiate sine of a inverse sine of x, and that means we'll get cosh of a inverse sine of x, but we'll need to multiply by the derivative of that, which again is another a over the square root of x squared plus 1, but we already have an a over the square root of x squared plus 1, so that's going to give us a squared over x squared plus 1. So now we have we've got y, we've got dy by dx, and we've got d2y by dx squared. So what we'll want to do is we'll now need to find x squared plus 1 d2y by dx squared, and that, if we're multiplying that by x squared plus 1 to the power of 1, then we're going to have a minus ax sine of a inverse sine in the numerator, but the denominator now is just going to be x squared plus 1 to the power of a half. And then we're going to be multiplying this bit by x squared plus 1, so the denominators will cancel out, and just notice that cosh of a inverse sine is actually y. So here we're getting a plus a squared y. We're then going to add on x lots of dy by dx, and adding that on, so x lots of dy by dx is going to be ax sine a inverse sine, again over x squared plus 1 to the power of a half. And now you'll see that these two are going to cancel out, and then the last thing we have got to bring in is minus a squared y. So we're having a minus a squared y, and that of course will cancel out over here. So if I just do it in a different colour, and hopefully you can see that this is going to cancel out with that, and that is going to cancel out with that. And so we have shown, in effect, what we have shown is that x squared plus 1 d2y by dx squared, we'll just get it in I think, plus x lots of dy by dx minus a squared y is equal to 0. So there were 5 marks for that particular bit. So if we just look at how we get the marks there, so the marks were given for, first of all, you got a method mark and an accuracy mark for your use of the chain rule in finding dy by dx. You also got a method mark and an accuracy mark for using the product rule, so that's 2 marks, and then you just got 1 mark then for showing that when you added those 3 expressions together you ended up with 0. So don't forget that if you want to access further revision videos, then you can do so by going to the Further Maths Support Programme website and following the link.